So hello everyone, in the last session we are discussing about the equivalent resistance and we have also seen about the Wheatstone bridge, and I have given you some homework also. So let us discuss the homework and let us continue our discussion. Okay. So I hope you have solved all the homeworks which I have given to you. So one of the homework which I able to recall is this one. With this question you have to find the RAB. So basically what is the approach? I told you the method, that is a potential approach. 85% of your question will be solved by the potential approach. So what you have to do, simply just apply the potential. Let us the potential V will be here and 0 is here. So if this is 0, this will be V. Can you write the potential here? You can't. So let us take it as X. So this will be also X and this will be V. Similarly this is 0, so this will be also 0, and let us take it as Y. So this will be also Y. Okay, now let us draw this. This is V, this is 0, this is my X and this is my Y. You can see between V and X we have a one resistance, correct? Between V and Y we have a one resistance. Between X and Y we have a one resistance. Between X and 0 we have a one resistance. Between Y and 0 we have a one resistance, if you can see, and we have to find the equivalent resistance across this. So what is this? This is a Wheatstone bridge. If this is a Wheatstone bridge, I can remove this resistance, correct? So what is my R equivalent? This is R 2R parallel with R, that is R. Simple. Similarly, come to here. This is also V. Let us take it as V. This is 0. If this is 0, this will be also 0. This will be also 0. Here you don't know. Let us take it as X. Okay. This is V, so this will be V. Here you also don't know. Let us take it as Y. This will be also Y. This is 0, so this will be also 0. Now let us draw it. So we have again 4 points: V, 0, X and Y. Between V and X we have a one resistance. What is the value? That is A2. Correct. Between V and Y, that is we have a 12 ohm. Between Y and 0 we have a 2 ohm. Between X and 0 we have one resistance, that is 12 ohm. Anything else? Between Y and 0 we have one more resistance, that is 3 ohm. Okay, so we have one more resistance, that is 3 ohm, correct? Anything else left? Between V and Y we have a 6 ohm. Between V and Y 12 ohm as well as 6 ohm. So this is 6 ohm, correct? So V and Y will be done. Y and 0 is also done, I think so. And then Y and 0 also done. 0 and X is done. 0 and X, yeah, 12 ohm. Then 0 and X again 12 ohm. Yeah, again two 12 ohms are there. This is also 12. This is also 12. So this is also 12 ohm. 0 and X, correct? Oh, sorry, I did something wrong. Sorry. You can see here, this cannot be a 0, na? Sorry, because here there is a resistance. Okay, so this won't be 0. This is X, so that means this will be X. Okay, so between X and 0 again, same structure will be same, but yeah, conceptually it will be wrong, na? Okay, and between V and X we have a 8 ohm. Between V and X we have a 8 ohm. Anything else? Y and X, between Y and X we have a 2 ohm. Correct. This is my structure. What is this resistance? V and Y, 6 ohm. And this is how much? Y and 0 we have a 3 ohm, and Y and 0 only 3 ohm is there. Okay, this is also not here, correct? So this is what you got. Now just solve it simply. 6, and I think it will be a Wheatstone bridge, yes or no? Or if it is not becoming a Wheatstone bridge, then there is also a method to solve it. This is becoming 6 ohm. 6 and 12 is how much? 6 into 12 divided by 6 plus 12. That is how much? That is 4 ohm. This will be 4 ohm. This is 8 ohm. So ratio will be 2. Now here 12 12 means 6. So here I have to give 3 ohm only. 3 and 6 2 are same. They are in Wheatstone bridge. So this will be, if it is Wheat, this can be removed, correct? So what you are getting? This is 8 and this is 6. So 8 plus 6 is 14. 14 parallel with, this is how much? This is 4, correct? This is 4 and this is 3. So 4 plus 3 is 12. So this is my R equivalent. 14 parallel with 14 parallel with 12. If you calculate 14 parallel with 12, you, how much you will get? 14 into 12 divided by 14 plus 12. That is how much? 26. So correct, 2 6 12 13. You will get 16 into 14. How much? 84 divided by 30. Correct. So this is how much you will get the answer. I hope these questions are clear. What you have to simply do, you have to redraw. In most of the question you have to do the same thing. You have to redraw and you have to calculate the R equivalent, and only the potential approach you have to apply. I hope it is clear. And one more thing, whenever you are seeing a 5 or more resistance, 5 resistance, or you can say 6 resistance, generally 5 or 6 resistance, always think about the Wheatstone bridge. Most probably it will be always a Wheatstone bridge. Clear? I hope it is clear now. Let me give you some more examples. Yeah. Can we go further? Okay. So let us take one more example. One more example. Basically, this is resistance R. This resistance is also R. Okay. And this resistance is also R. R, R, and R. Then after that, this resistance is also R. This resistance is also R. And suppose this resistance is also R. Correct? This point is A. This point is B. Okay? And my question is, you have to find the R equivalent between A and B. This point, or you can do find R equivalent between, suppose this point is A and B, between these 2 points. How will you solve? Okay? Between these 2 points, how will you solve? How will you solve for this question? See, if you try to analyze this question properly, what you can observe from this question? What is you can observe from this question? You can observe that, see, just remove this part and try to see this thing. Here, how many resistance are there? First of all, 1, 2, 3, 4, 5. 5 resistance. This means there can be a possibility of Wheatstone bridge. Just give me 1 minute. Okay, so that means there can be there can be a possibility of Wheatstone bridge. That can be possible from here that we are getting. So let us check. Let us, this point is A, this point is B. So let us, potential of this point you take it as V, and this point potential is 0, and this point as a X. Okay, and this point is Y. Correct? Any other point is left? No. So let us draw again. This is my V, this is my 0, this is my X, this is my Y. Correct? Okay. Between V and X, first between V and X you have a resistance R. Then between X and 0, you have a resistance R. Correct? Okay. Then between X and Y you have a resistance R. Between V and Y, you have another resistance that is called as a R. Between Y and 0 you have another resistance called as a R. And between, one more resistance is there, if you see properly, that is which resistance? Between V and 0 we have a one resistance R, means we have another resistance R from here. Correct? This is R. So how to solve? See, this thing is Wheatstone bridge. So I can remove this resistance, correct? So these two will become how much? See, this whole thing will become like this. If you try to understand, there is a one resistance R is there between V and 0, correct? Okay, this is 2R, this is 2R, correct? 2R parallel with R, okay? So you will get R final, and there is a one resistance R below also. So what is net? You will get R by 2, that is R net, correct? So this is my net resistance. Clear? Any doubt is there? So this is how you can calculate the equivalent resistance. Clear? Now this is valid only when you are getting a Wheatstone bridge. Suppose let us take an example when there is a no Wheatstone bridge formation is there. Okay. Example, when there is no Wheatstone bridge. Sorry. Means when there is no Wheatstone bridge. For that you will use by VI method. Okay. What is VI method? Let us understand it by an example. Okay. There is no theory I am going to tell you. Just I am writing one example. You can understand from that example. Suppose this is 1 ohm, correct? And suppose this is 2 ohm. This is also 1 ohm. This is suppose 2 ohm. And suppose this is 1 ohm. And this is whole is connected to a battery of suppose 2 volt. Okay. Now the question is, you have to find the R equivalent. You have to find the R equivalent. The thing is that how will you find the R equivalent for this? Because if you can see, the ratio of these two are not equal, so we can't apply the Wheatstone bridge. So how to find this? See, I am sure that this I current will, this battery will give a current I. That current I will going to distribute into I1 and I2, correct? And that current will come out here again as I. So what is my resistance? R net I can write. R net will be sure that it will be 2 volt. Suppose let us take some general case, not 2 volt. Let us make it general. Assume there is a battery. Suppose V volt is there. Then in that case, make it general, okay? Then in that case, what is the approach? Just apply a voltage source of battery V. So what is my resistance? V by I, correct? Or you can say it will be my V by I1 plus I2, okay, correct? This will be my resistance. This is my R net. So if I calculate my I1 and I2 in the terms of V, I can directly write my resistance. So what is the approach? See, I told you one method by which you can solve any circuit, that is by KCL, by simple KCL approach. So let us apply the KCL approach. What is the KCL approach? Tell, first take the potential at any 1.0. If this is 0, this will be V, that is we know. If this is V, this will be also V. This potential you don't know, let us take it as X, correct? This is 0, this will be also 0, this will be also 0, correct? This also you don't know, let us take it as Y. But okay, let us take it as Y, no problem. This will be 0, this will be V. Now every point you know the potential. So first apply, what is the first step? I told you, first apply KCL at X, okay? So if you apply the KCL at X, what is the approach? What is the approach? When you are applying a KCL at any node, just see that node, don't consider about anything and in the like circuit, don't think about of anything, just consider that node. So let us current, you take here the current is going, here the current is going, like that you consider like this, okay? Just you are for applying this node, okay? So what is the value you will get? X minus V upon 1 plus, sorry, 1 minute, just give me 1 minute. Yeah, so it will be X minus V upon 1 plus X minus Y upon what is 1 plus X minus 0 upon, sorry, 2 equal to 0, correct? Similarly, if you solve this equation, what you will get? You will get 2x minus 2b plus 2x minus 2y plus x is equal to 0. So what is the value you will get? This is 415x minus 2y is equal to 2v. Correct. Similarly here also. Similarly at node y, if you write for node y, what is the value you will get? That is y minus v upon 2. Correct. Y minus v upon 2 plus similarly y minus x upon 1 plus y minus 0 upon 1 is equal to 0. Then you multiply by 2. Okay, so what you will get? Y minus 2 plus 2y minus 2x plus 2y is equal to 0. Okay, if this is the thing, what is the thing you will get? That is 3y 4 that is 415y minus 2x is equal to v. Now you have a 2 equation and 2 unknown. Just solve for x and y. Correct. So how to solve for x and y? The first approach you can see from here, either you can add these two equation or subtract these two equation. This is my equation number 2, correct, and this is my equation number 1. First approach is, what is the first approach? Let us go to the next page. First you add equation 1 and equation 2. Okay, that is my approach. First add the two equations. So what are the two equations? 5x minus 2y plus 2v. Okay, 5x minus 2y is equal to 2v. And what is the second equation we got? 5y minus 2x is equal to v. 5y minus 2x is equal to v. First add these two equations. What you will get? You will get 3y, okay, minus 3x is equal to 3v. That is y minus x is equal to v. Okay, that is equation number suppose third. Correct. Similarly, now you subtract these two equations. What is this? Is purely mathematics. How you solve? For generally only for NEET student I am telling this method. Otherwise I won't tell. Okay, just you subtract these two equations. So when you subtract, here now you subtract. Okay, subtract 1 and 2. Okay. So when you subtract, what you will get? You will get 7x, correct, minus 7y, correct, and this how much you will get? V. So from here you get x minus y is equal to how much? That is v by 7. Now you take this equation as 4 and now solve these two equations. Okay, so how to solve these two equations? First you have to calculate x and then you have to calculate y. 1 minute. X you will get okay. Okay. You just do one thing. What is the value of y you are getting from here? What is the value of y you are getting from here? Y value is v plus x, correct? You just put it into this equation. Okay. Or we can do one more thing. In spite of doing all these things, we can directly do one more thing. Let me do one more thing. We can do directly one more thing. See, this is our equation 1 and 2. We can directly substitute the value of x in term of y. So what is y you will get? Y will be 5x minus 2v divided by 2, correct? And what is the value of x? If you put the value of x, you find out the value of x. What is the value of x? 5y minus v divided by 2, correct? You just put it here. So what is the value of y you will get? That is 5 into 5y minus v divided by 2 minus 2v divided by 2, correct? So what is the value you will get? You will get 2y is equal to, that is you multiply, you will get 25y minus 5v divided by 2 into 2v. So you get how much? That is 4y is equal to 25y minus 5v and minus 4y v, correct? So from here what you will get? You will get how much? Just take this out. You will get 9v. You will get how much? 25 minus 4, that is 21y. So how much you will get? Y is equal to 9v by 21, or you can write it as 7 Vy, sorry 3 Vy 7. As you get y, you put it here. 5 into 3 Vy 7 minus V divided by 2. So how much you will get? 15 minus 7. 15 minus 7 is how much? 8. So 8 V by 2. So you will get 4 V by 7. Now you know the value of x and y. So what is my I1? I1 will be how much? If you will see, what is the value of I1 here? It will be x minus b by 1. Okay. What is the value of I1? It is x minus b by 1. What is the value of x? X we will got as 4 v by 7. So 4 v by 7 minus v divided by 1. So that will be 3 v by 7. Correct. And what is I2? Can you tell me what is I2? See, I2 we have got, if you see here in the circuit, what is I2 we have? I2 is nothing but v minus y by 2. Okay. So I2 will be v minus y by 2. What is y? V means 3 v by 7. Correct. So v minus 3 v by 7. Sorry, this will be minus, but we are not considering about sign. Basically it will be minus here. Why it is I am writing like this? Because I1 is opposite of this current. Now I am writing the current like this, so I1 will be just opposite. So if you are writing I1, so you have to take minus sign. Okay, that thing we have discussed in the earlier class also. So from here what you will get, that is 2 v by 7. Correct. So I1 I2 you will get. So what is my R net? Then my R net will be very clear, that will be equal to V upon I1, that is 3 V by 7 into 2 V by 7. So V cancel out, you will get 7 by 5 ohm. That is my R net of this circuit. So if you see, so that is my R net of this circuit. So this circuit is not a Wheatstone bridge, but we are able to calculate the R equivalent. And what is the R equivalent for this circuit? If you see, the R equivalent for this circuit is 5 by how much? 7 ohm. What is the answer? Sorry, not 5 by, it is 7 by 5 ohm. 1 minute. Yeah. So here we are getting 7 by 5 ohm as my equivalent resistance. So what is the approach you have to do? You have to simply consider the current in the branches and then try to write the current in the term of voltage, and then it will be automatically cancel out and you will get the, basically what is the approach you have to use? You have to use the approach of KCL, how we can use the KCL to solve the circuit. I hope till here everyone is clear, like how to calculate the equivalent resistance. Generally this type of question won't come in the exam, but it is better if you know the method. So this is my third method to calculate the equivalent resistance. Clear? Please note it down. Okay. So let us discuss about next method. What is the next method? Method number. See, this is the method we are saying. This is third method, you can say. If you remember, what are the different methods we have discussed till now? So first method we have started is the potential method. First is the series parallel method. In series parallel method we have discussed, and then we went to the potential method. Then after that potential method we went to the next method, that is called as a Wheatstone bridge method. Then we have seen the VI method, and the last method, and now next method we are going to see is the, that is called as a symmetry method. Okay, that is called as a symmetry method. Symmetry methods. Now question is that what is that symmetry method? See, there are two types of symmetries are there. Okay, so there are two types of symmetries. Symmetries. Okay, so there are two types of symmetries are there. What are those two types of symmetries? The first one is called as a vertical symmetry. Vertical symmetry, or you can say vertical plane symmetry, या vertical mirror symmetry, whatever name you want you can call it as, it doesn't matter. Basically name is not important, the method is important. And second is called as a horizontal plane, or you can say mirror symmetry, correct? So these are the two methods are there, okay, and we have to understand these two methods with the condition that when we are applicable and how to solve this question, okay. Basically the question is that where you will apply this method, okay. So let us first discuss about that is vertical plane symmetry, okay. Vertical plane, or you can say mirror, 1 minute, or mirror symmetry. Now what is this? Let us talk it about this. Clear? So let us talk about this. That is, what do you mean by vertical mirror symmetry or vertical plane symmetry? Basically, first condition is that where to apply. That is important. Where to apply. See, the condition I am telling you where to apply, but you will learn better when you see the example. It is applicable when the point between which you have to find R equivalent is perpendicular to the mirror is symmetric. Are you getting my point? Miss, suppose these are the 2 points. Basically let us see example, then you will better understand. Let us talk about the example on this, okay. Let us talk about the example, then it will be more clear, okay. And in spite of talking like that, if we take more examples, then it will be more clear. So let us take me a one example. Okay, so suppose this is the example I am taking. Okay, this is R, 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 this point is A, this point is B. See, first thing what you have to see whether there will be any plane, that divide the circuit into the two equal parts. What is the first thing you have to see while solving this symmetry? Step 1. I am writing the step here for you. What is the first thing you have to see? There is any plane that divide the circuit in two equal part, okay, two equal part, correct. And remember that plane will be that plane should be should be sorry should be either perpendicular or the or or parallel, not or the not perpendicular, perpendicular, one minute, perpendicular or parallel to the points where R equivalent is calculated. Correct. That is the first step. Okay. So what you have to do? You have to basically first see the plane which is going to divide the circuit into the two equal part, and that will be only two what is the condition on that plane? The plane should be either parallel or perpendicular to the points which is going to be across which you are going to calculate the R equivalent. So if you see here, you can see what you can see. You can see that there is only one plane. There is only one plane is here, which is going to divide the circuit into the two equal parts. That is this plane. Correct. Okay, and that is the 2 points where you have to find the R equivalent. Correct. So this plane is basically perpendicular, yes or no? This plane is perpendicular to this. Correct. Are you getting my point? This plane is perpendicular to this. Correct. 1 minute. This plane is perpendicular to this. Correct. So if it is perpendicular, sorry, okay, step 2, and if it is perpendicular plane, then apply vertical plane symmetry, VPS. How to apply? Now this is a now that means the vertical plane symmetry is applicable here. Now what is the approach you have to apply? Suppose the I current, you have to assume that there is a battery of V volt is there. Correct. You have to assume there is a battery of V volt is there. Correct. This will send a current I. So here we'll also have a current I. Now this current is going to be divided into two current, that is I1 and I2. I1 and I2. Okay. And if it is like this, if it is going to be divided into I1 and I2, and if it is a mirror, you have to keep a mirror here. And if it is a mirror, if there is I1, there will be also I1 in this side, correct? Because it is a mirror, no? So a mirror image will be here also there. Now if it is I2, this will be also equal to I2. And if it is I, then this in this branch also we have I, correct? Just look at here till. What I am trying to say, if it is a mirror, whatever the current is coming, the same current will be outgoing. Correct. Then you can understand from here, see I1 is coming here, and here he has to divide now, but he haven't divided, it went to I1 here. That means no current is going in this branch. Correct. Similarly here also you can see I2 is coming here, it should divide, but he haven't divided, it all went through this resistance. That means no current is went to in this branch. Correct. So can I remove this branch? The answer is yes, we can remove this branch. So what is our circuit will become? Our circuit will become like this. We have R here, we have R here, we have another resistance R here, and we have another resistance R here. Now you can find the R equivalent across this. This is RR, 2R parallel with 2R. So what is the value you will get? R. Answer. This is clear? Simple approach, simple method. That is called as a vertical plane symmetry. Let us see one more example. Okay. correct? A point, this is B point, okay? Okay, this is the case, and all resistance are R, 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 R. This is also R, this is also R, this is also R, and this is, you have to find R equivalent. First of all, test whether there is a vertical symmetry or not, and then try to solve it. Clear? So first, there is a vertical symmetry. Answer is yes, there is a vertical symmetry here. You can see like this. I think I have drawn it not straight, but yeah, you can get the point. No? There is a vertical symmetry. So if it is like this, so suppose there is a current I is there, so I1 will be there and I2 will be there. And if it is a vertical symmetry, obviously this I2 will go here. So there I2 should also be here also, and I1 should also here also. Correct? Are you getting my point? Okay. And I should be here also. So what we can judge from here? See, I1 current is coming. Here it should divide, but it is not getting divided. That means what we can say? What we can say from here? And one more thing. This line is not there, okay? Otherwise you consider this as a line. This line is not here. Let me make it. Otherwise you will get confused. Okay. So obviously we can say that this point is not joined. We can say that this point is not joined because whatever the current is coming, it not getting here. It will be that means this point is not joined. So we can draw this circuit in this way also. Basically we have 2R, correct? And if this point is not joined, this will be also 2R, correct? And this is also 2R. Correct or not? Huh? Okay, this is also correct. And one more thing, oh sorry, this is I left, there is a one resistance R there, no? Sorry. Okay, so this resistance is also R and this resistance is R. And there you have to find R equivalent. Now it is a simple question. 2R is R, R plus R plus R, that is 3R. 3R parallel with 2R, how much? R net, that is 3R parallel with 2R. How much you will get? You will get 6R square divided by 5R, that is 6R by 5 ohm. R net. Simple answer. Clear? So that is how you can apply the vertical plane symmetry in any one of the question, and you can calculate the R equivalent of that circuit. Okay, I hope you understand how to apply the vertical plane symmetry. See, it is not always true. We can apply the vertical plane symmetry also, and the next symmetry we have is the horizontal plane symmetry. Okay, next symmetry is what? That is called as a horizontal. Next is horizontal. Okay, horizontal plane symmetry. Okay, what is horizontal plane symmetry? What is that? What is the meaning of a horizontal plane symmetry? Let us talk about. See, horizontal plane symmetry simply means there we have applying in horizontal plane symmetry. Vertical plane symmetry, if you try to understand in vertical plane symmetry what we are doing, if you see, we are applying this symmetry basically when there is a perpendicular to the plane, perpendicular, you are seeing the perpendicular, okay, mirror between the 2 points here in this case. Find plane parallel to the point where R net is calculated. Means where we have to calculate the R net. where you have to calculate R net, just apply here. Clear? Calculated. Clear? There you have to apply horizontal plane symmetry. Now let us talk about, I will discuss one example that will make your all picture clear. Okay, let us take one example. So suppose this is my diagram. It take me little time to draw the diagram, just wait a minute. This is R, and suppose this is also R. Okay, this is also R, and suppose this is also R, this is also R, and these two are joined here. Okay, and same thing is here also, R, correct, this is also R, this is also R, correct. And what is my question? My question is you have to find R equivalent across AB. Okay, across AB. Clear? This is also joined, correct? Clear? Now if you see properly, can you apply horizontal symmetry? Answer is yes. How? See, this is the 2 point across which you have to find the R equivalent. And if you see this plane, which plane? This plane. So this plane is going to divide the circuit into the two equal parts. Similarly, this plane is also doing. Similarly, means here both the symmetries are applicable. This is vertical plane symmetry and this is horizontal plane symmetry. Okay, both the symmetries are applicable. Whatever symmetry you want, you can apply and solve. But here it is better to apply a vertical plane symmetry. Why? Because we are learning about horizontal plane symmetry, so we will solve it by horizontal because that is more easy. How to do? Let us see. Okay, just I am removing this thing. Okay, because we are not going to apply the vertical plane symmetry here, but I am telling you here it is applicable. You can see how it is applicable. So let us talk about horizontal plane. What you have to simply do, you have to take this point as x. This point is A is given, B is given. Let's take this point is as x. This is at y. This is at z. Okay. If this is x and it is a mirror image of this, so if this is x, this should be also x. If this is y, this should be also y. Correct. Okay. If this is z, this should be also z. Okay. What about this point? This point is A. Okay. This point you take it as O, and this point is you take it as B. Correct. So what you got from here? If you see A and O, one resistance is there, R. Correct. And then O and B, we have one resistance, R. Correct. This is my point A. This is my point B. Now let us try to draw it. See, between X and A, we have a resistance R. And between again X and A, we have a resistance R. So I can directly draw, means R by 2. Similarly, this one, A and Y, similarly A and Y, or you can say X and Y, that means it will become R by 2, correct? Similarly, Y and X, R by 2. Basically what you have to do, you have to do the half of all the resistance. Whatever the resistance are there, just do half of all the resistance. You will get the solution. That is a simple approach. That is why this is more easier. Just you have to do the half of all the resistance. Done. This is solved. This part is solved. Half of the circuit is solved. Now here again what you will do. Now here you can apply, sorry, 1 minute. Here what you can do, here you can apply now vertical symmetry. Now what? Apply the vertical plane symmetry. Now if you apply the vertical plane symmetry, what will happen? So let us suppose in vertical plane symmetry, if there is a current I is there, this is current I1 and this is current I2. So here also the current I1 will be there and here current I2 will be there. Then obviously this will be get disconnected, correct? This will be disconnected from here. If it is disconnected from here, what you will get? R by 2 plus R by 2 is R. So there will be resistance R will be here. R by 2 plus R by 2, that will be also R. So there will be resistance R will be here also there. Okay, correct. Now there will be one resistance R by 2 here. and there is a one resistance R by 2 will be here. Now you can say these two resistance will be in series, that is 2R, correct? So this is the how you will get the R equivalent. See, R by R plus R, that is R by 2, that is 3R by 2 parallel with 2R. So 3R by 2 will become parallel with 2R. So if you calculate what is the value, you will get 3R square divided by, that is 7R by 2. So what is the value you will get? You will get 6 by 7 R ohm is the answer. Clear? So this is the best example of horizontal plane symmetry as well as the vertical plane symmetry. Now I hope you have understand how to apply the horizontal plane symmetry and how to apply the vertical plane symmetry. I hope till now here it is clear. If it is any doubt, please let me know. Just note it down. Clear? Okay, let us take one more example. It will take me time to draw this question because it is a big question. Okay, or let me use, okay, let's do one thing. Let us do one thing. Okay. Okay. Clear? So suppose there is a one resistance R, there is another 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 resistance R, this is also a resistance R, this is also a resistance R, correct? Till here anything is doubt? Okay, so this point you take it as point A and this point you take it as point B. Okay, and you have to find the R equivalent across point A and point B. Okay, that is my example. This is the one question you have to solve. So first you have to think which type of symmetry is applicable and then you have to try it. Okay, so which type of symmetry you can see we can apply. See, it is very clear which type of symmetry we can apply here in this case. Obviously vertical symmetry, vertical plane symmetry, correct, like that. If you can see, we can apply that thing. So let us apply the vertical plane symmetry here. So if you apply the vertical plane symmetry like this, here like this, if you apply, how will you solve? Sorry, yeah, how will you solve? Just tell me, like, how will you approach it? Okay, so what is the basically approach? What we will do if we are applying a vertical plane symmetry here? One minute. Okay, so what you will do for calculating the R equivalent for this case? Whether you can apply the vertical plane symmetry or horizontal plane symmetry, that first thing you have to clear. See, if it is along the points where you have to find the R equivalent. So here you will apply sorry, excuse me. So obviously here you will apply horizontal. It is a horizontal symmetry. If you see properly, it is a horizontal symmetry. So what is the approach? Take this as x, this is y, and let us some point, this point will be some z. Okay, so if this is x, this will be sorry sorry 1 minute. If this is x and this some z, okay, so this is x, this will be also x, this is z, so this will be also z, and this will be, take it as some y na, otherwise this will be a problem. So if it is this is b is given na, so no need to take some another point. So this is z. Okay, so now if you see it, we can draw it like this. This whole circuit will reduce to this part, this thing. This is r by 2, sorry, not r by 2, it is r na, yeah. So this is r, this thing you will see, this point is a and z, this point is also a and z, so this will reduce to r by 2, correct? So this will reduce to r by 2, correct? Now you will see here, this point, this is between z and z, so you can remove this resistance. Now this has become r by 2 again, okay, or I can draw it like this simple manner, no need to draw it like this. So this is again we have r by 2, and this thing we have again r by 2. I am removing this circuit because it is between the same point, potential difference is 0, current will be 0. This is r by 2, this is also between x and x, so I can remove this also, okay. So this also will be removed. Now you are getting this resistance between v to x, okay, r is there, this resistance is there, r is there, okay. And what is point A and B? This is a point A, okay, and this point is point B. Now you can simply solve, then no problem. What is the problem here? See, r by 2 is how much? That is r, correct? R plus r is 2r, 2r parallel with r. So RAB is how much? 2r parallel with r. That is how much? How? 2r parallel with r is how much? 2r by 3. Answer. Clear? I hope no doubt is there. That is a simple approach of applying this. Clear? Okay, let's take one more example. That is a question from DC Pandey. Okay, this will clear your all concept regarding this thing. Let me draw it. It will be slight difficult to draw. Okay. We can do one more thing. Just try to understand the diagram first. Okay. Then only you can solve it. If you don't understand the diagram, you can't solve this. Okay. I hope the diagram is clear to you, and you treat it like this. Okay, just try to like understand the diagram. The diagram is slight complicated, not that much, but yeah, slight. It will be difficult for you to understand, but try to understand this, because in the exam they will ask you this type of questions only, where you have to think about the diagram, like how it is made. Okay, So you can see now there are the 4 rhombus within one rhombus. I hope you are getting my point. Okay, now it is clear. Okay, so suppose this type of circuit is there, you can put one more also if you want, and suppose this is my point is A and this is my point is B. Okay, so let us put the resistance. Suppose this resistance is R. Okay, this resistance is also R. This resistance is also R. R, 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 R. So this is the complete circuit. Clear? Now you have to find the RAB in this. That is my question. How to calculate? Just think for 2 minutes and try to calculate RAB. How will you find the RAB for this? Which type of symmetry you can see? So first symmetry which I am able to see in this is which symmetry? See, there one symmetry is very common to here. That is horizontal plane symmetry, sir. Which symmetry? That is horizontal plane symmetry. So if it is horizontal, so let us, this point is X, this point is Y, this point is some Z, and this point is some P. Correct? This point is O, this point is suppose R. Correct? I have named all the points. So this is Y, so obviously, or this point is also there, na? So this points you take it as some alpha. Okay, this point is some beta. Okay, and this point is some gamma. This is S, alpha, gamma, Y, beta, gamma, Z, sorry, Z, gamma. This point is some P, correct? This point is R, this point is O, correct? No need to type because R is there, so you can take it as some OM. If this is X, obviously this will be X. This is alpha, this will be alpha. This is Y, this will be Y. This is beta, this will be beta, correct? This is Z, this will be Z. This is gamma, this will be gamma. This is P, so this will be also P. So I can directly convert this into this question. You see, understand, this whole thing is converted into this form. What is the form? It will look like it will look something like this. Okay, let me try to explain you. Basically what it will become something like this. There will be one resistance R by 2, because this R will become parallel in R, so R by 2. This is also R by 2, correct? Then here also we have R by 2, correct? Here also we will have R by 2, correct? This is also R by 2. This will be also as R by 2. Clear? And this is my output. Now this you take it as, this is also R by 2, correct? This is also as R by 2. This is R by 2. This is also R by 2. Clear? And these 2 points are joined. Now here you apply vertical symmetry again. So vertical symmetry, that means current I is here, so I1 will be here and I2 will be here. So obviously here also this will be I2 and this will be I2 and I will be here. So that means these 2 points are not joined together. So just remove these 2 points. So when you remove these 2 points, what you will get? See, now it will become very simple. R by 2, R by 2, R by 2, R by 2. So 4R by 2 means 2R. So this will become in numerator, that is 2R. Correct? R by 2, R by 2, R by 2, R by 2. So this will become also 2R. Correct? Then there is a 2R resistance will be here. R by 2, sorry, not R by 2, R by 2 resistance will be here. So what you are getting, 2R, R plus R by 2, that is 2R by 2. 2R by 2 means R, and R2R parallel is R. So what is R equivalent for this? R net will be, that is 2R for this circuit. Okay, R equivalent will be 2R for this circuit. If you remember, for this circuit, what is the R equivalent we have got? R, and we are repeating twice. So obviously the R equivalent will be 2R. Like that you can also think. Okay, I hope you have understand. Like if you have any doubt, please let me know. Basically, this is also example where both horizontal plane symmetry and vertical plane symmetry both are applicable. Okay, horizontal plane symmetry and vertical plane symmetry both are applicable. So these are the few examples we have seen on the horizontal plane symmetry and the vertical plane symmetry. So basically we have seen all the methods to calculate our R equivalent. Okay, so we have seen all the methods to calculate our R equivalent. In the next class we will see the cube, like in cube how to calculate the R equivalent for the body, for the face, for the edges, and next we are going to see about the infinite ladder case. Okay, in that case we will see some special cases also, and then we will go for the next thing, that is our basically battery, combination of battery and other topics. Okay, till then take care, and if you like this session, please like it, share it, subscribe it, and have a nice day. Thank you.